So we don't want to waste. So now today's class, so we are going to start the next important concept for JEE, mains as well as NEET. So that is what gravitational potential energy. So you might be remember class 9th, you might be studied types of potential energy is two types. One is elastic potential energy. Another one is gravitational potential energy. Am I right, everybody? All of you? So that is only is our concept, gravitational potential energy. So which is also for IIT JEE mains and as well as NEET. So if you notice it here, this is also one of the important and easiest concept. Just if you understand the concept, numericals is very simple to solve. So now if you take the gravitational potential energy, GPE, gravitational potential energy for any system. So here there is a certain rules. Already when I'm teaching the change in kinetic energy of a system and potential energy of a system, I already told you potential energy of a system does not existed. Always what will exist, everybody? Always we used to calculate not a potential energy of a body. What we used to calculate with this one? Change in potential energy of a body. So if you take any kind of body, please remember, for example, if I take a mass M, and if I want to know, so certain point away from the mass M, which is where the distance is R, then we all knows that electric field E is equals to, what is the formula? E is equals to everybody? Gravitational field E is equals to minus Gm divided by R square. Am I right, guys, everybody? So which is a vector quantity. And what is the potential? Anybody? Gravitational potential is equals to, for this one, single mass. Please speak, guys. Minus Gm divided by R, which is actually a scalar quantity. Now, if I take a single mass, please keep it in mind, the potential energy, that is what gravitational potential energy is 0, because for a single mass, potential energy can be defined or cannot be defined. Everybody? Not be defined. That is what is the most important thing. So that is why always gravitational potential energy or potential energy, if you take, always how many bodies you have to take it, everybody? Single body, no potential energy is existed and it's not, we cannot define it. So always if you want to speak about the gravitational potential energy, minimum how many bodies? Minimum not. How many bodies it is? Always you have to take the pair of a body. That is what, let me take mass M1 and M2, where the distance is R. Then the gravitational potential energy between these two bodies, which is equals to minus G into M1 into M2 divided by R. And also one more thing, in physics, it is not possible. I already taught you this. In physics, it is not possible to define the U. So in physics, only we can define what, guys? Everybody? In physics, only we can define change in U. Do you understand, everyone? So change in U we can define, not U will be defined. So U cannot be defined. Always what we can define, everybody? We can define change in potential energy. So remember, if I take the change in potential energy, which is equals to minus of, which is equals to something, can you tell me, everybody? So which is equals, I'm saying you, minus of W, work done by only conservative internal forces. So can you tell me what is the example of internal conservative forces? Conservative or non-conservative forces I have taught you. Anybody? What is the example of conservative forces, guys? Gravitational force, spring force, electrostatic force. These are called it as a conservative force. Simply, sir, we'll listen. We won't say anything means nothing is going to work out. So, change in potential energy is equals to, what is the formula, everybody? Change in potential energy means, speak, final potential energy minus initial potential energy is equals to minus of work done. Minus of work done. Work done by what, everybody? Conservative internal forces. What is the examples of conservative internal forces, everybody? Gravitational force, electrostatic force, and spring force. So we know all are non-conservative forces. Can you tell me what is the non-conservative forces, everybody? What is the example of non-conservative forces? Pradosh? Non-conservative forces example I'm asking. Anybody? This is what people are studying. How many days I have taught you that? Anyone? Yes, Rudreshwa? Friction. Friction is the example of non-conservative force, where here if you talk about the potential energy, gravitational potential energy, only work done by the conservative internal forces. So if you take all these cases, delta U, change in potential energy equals to minus of work done, that is what conservative internal forces. So there is no external forces exerting. So according to that, I can say there is no change in velocity because no external force is exerting, only work done by the internal forces. So kinetic energy should not change. Should not change means velocity remains constant. Where is everybody? Velocity remains constant. That is what you have to remember it. So what is gravitational potential energy means? Final potential energy minus initial potential is equals to minus of work done by conservative internal forces. That force is only, what is that force? Everybody? Conservative force, which is call it as a gravitational force. So this is the formula for gravitational potential energy. So now, if you take any kind of configuration, so configuration means if you take 2 bodies or 3 bodies, minimum is 2 bodies, 3 bodies, 4 body configuration, 5 body configuration, 6 body configuration, 10 body configuration, doesn't matter. So always this is the formula for gravitational potential energy. Of course, we will solve the numericals also in our today's class. So by the time you'll understand. So for example, let me take 2 body configuration. So if I take any kind of system of configuration, for example, so let me take this is the point A and another point is this is the point B. So now initial potential energy of these bodies both are at a certain distance. Now after a certain time, so they both is attracted by each other and the distance between them is reduced. They become together. So definitely distance is changing. Am I right or wrong? Distance between the two bodies it changes or not? Please respond. All of you. So then there will be a definitely change in potential energy. So the change in potential energy, that is what final potential energy, which is minus initial potential energy equals to minus of work done by the gravitational force. So that is only call it as a gravitational potential energy. So if you take any kind of configuration, so please remember, if you take any kind of configuration, for example, imagine this B is at infinity. This B is at what, everybody? B is at infinity, basically. Or, sorry, not B, you take it as a. So let me take A is at infinity, means any mass is at infinity. I have to bring it to where, guys? From infinity to, anybody? From infinity to where I should bring? All of you. Infinity to point B. So let me take. So now this is what is my configuration. So if I take my configuration, that is what from instead of A to B, I'm taking entire mass is present at infinity distance. So if it is at infinity distance, please keep it in mind. What is the potential energy? Everybody? Initially, if it is at infinity, everything is zero. Potential is zero, electric field is zero, and as well as potential energy is also what? Everybody? Please respond. Zero. So this is the major assumption. Major assumption. That is what we used to say. It is a universal assumption which you need to made it actually. Clear, everybody? So from that I'll modify it. So we are bringing from where to where? Check it, everybody. Initially body is at infinity. So we have to bring it to the certain point. So let me take that point is be somewhere, whatever it is. So then what is this formula? Can you tell me, everybody? Final potential energy. What is the final potential energy? That is what U configuration. So final potential energy U configuration minus what is the initial potential energy? Initial potential energy presented where, guys? At infinity distance, which is equals to minus of work done by the gravitational force. Gravitational force in bringing each mass. In bringing each mass from what distance, guys? Everybody? In bringing each mass from where, everybody? Each mass from which distance? Infinity to configuration. So that is what. So we all knows that potential energy at infinity is zero. So what is the formula? U configuration. Potential energy of a configuration is equals to minus of work done by the gravitational force to bringing what, everybody? In bringing, please respond. In bringing each mass from infinity. So this is the formula for calculating potential, gravitational potential energy of a system. So that is what you have to remember. Are you clear, everybody? Please respond, guys, all of you.
Yes.
So now, let me take, there is a two bodies, one is M1 and another one is M2. So where the distance between them is R. Understand? Then, if I consider a body at initially is at infinity, so U infinity is 0. So if I consider, then what is the formula? U configuration is equals to, what is the value, guys? Minus G into M1 into M2 divided by R. So this is the formula for calculating potential energy of any kind of configuration. And what is the unit of potential energy? Anybody can tell? What is the unit of potential energy? Energy, Ra. What is the unit of potential energy? Speak, guys.
Joules.
Equals to joules. Okay. So now let us prove that. Now what will happen? How this formula will comes and why it is negative minus of work done by the gravitational force. So let us derive it and make it. All of you. Shall we start now, everybody? Are you clear, everyone? Please respond. Yes. So now let us prove that now. As I said, if I take a single mass, is it gravitational potential energy is existed, everybody? Yes, please. No. For a single mass, it is not possible to define the gravitational potential energy. So let us make this derivation. How this gravitational potential energy of a configuration is minus, what is the formula, guys? What is the gravitational potential energy formula? Minus of capital G into M1 into M2 divided by R. Okay, everyone, please respond, guys.
Yes, sir.
Yes. Now, let me take two masses. One is M1, another one is M2, which is present at infinity distance. Now, I want to bring this from infinity to a certain place where I bought only first M1. So now you can see, according to Newton's first law, unless and until a body is compelled by an external force, what is Newton's first law? Everybody can tell? Princey, what is Newton's first law, everybody? Unless and until a body experienced by an external force, which is in state of rest, remains in state of rest, which is in state of motion, remains in what? Yes. So please respond. Newton's, already we studied Newton's laws of motion. So according to the Newton's first law, what is that, girls, everybody? A body which is in state of rest remains in state of rest. The body which is in motion remains in state of motion. So now I have applied some force, whatever it is, and I try to bought the M1 mass alone for the particular place. Now I'm bringing a single mass. So can you tell me what is the work done by the gravitational force on the single mass, which is equals to what? Anybody? Single mass. Single mass. What is the work done? Everybody. Work done by the gravitational force, which is by the single mass, is always equals to what? 0. So remember, single mass is bringing means work done by the gravitational force, which is equals to how much, everybody? Yes, please. 0. Do you understand, Pradosh? So from infinity to particular point. Now, already M1 came here. Now, I want to bring the M2 to a particular distance. I'm imagining, imaginary lines I'm drawing. So I want to bring the M2 for a particular distance from the M1, which is at R. Then how much work done we have to do it to bring the mass M2 from a M1 by R distance. Then you all observe very carefully, work done by the gravitational force on 2, which is equals to how much? So how much it is means you can see. Maybe Pradosh will put very close to M1, Rudreswar will put very little far away from M1, and Laksha will put some other far away from the M1. So is it R is remains constant? Yes, Mr. Murali, Pradosh. Is it R is remains constant or varies? So R is defines varies, because from the M1 mass, wherever you want, you can put the M2. So that is what? From some X distance, I can put anywhere I can. So that is why R is remains constant or variable. Everybody. R is remains constant or variable. So variable. So if R is variable means then force also variable or constant or force is remains constant or variable or everybody. It is variable because it is F is inversely proportional to square of distance between them. So it is varies. So if it is varies means we all knows that. Can you tell me anybody from previous chapters? Work done is equals to what? Variable. Variable means work done is equals to what? Anybody? integration of f dx. That is what it is for variable. Am I right, guys? Please respond. Everybody? Clear? Everyone? Respond, Ra. So that is what?
Yes,
so
sir.
if it's a variable, then work done by that body too. The gravitational force due to the 2 is integration of f dx. Can you tell me the roots, limits? Limit is from where to where? Infinity to particular distance, I will take it. The distance I will consider as a what? Everyone? Yes, please. R. So limits is from infinity to R. So you can make it and substitute it. So integration from R to infinity to R, F value is what is that, everybody? Minus G into M1 into M2 divided by X square into dx. So now in this something is constant. Anybody can tell? Something is constant. What is that? Minus G M1 M2 is constant. So integration of infinity to R, which is equals to 1 by x square into dx. Now I won't teach you anything. You should tell me fastly. 1 by x, integration of 1 by x square into dx, which is equals to how much? Make it quick, everybody. Fastly. 1 by x square means I will write 1 by x square means x power minus 2 dx. What is the formula, everybody? X power n plus 1 divided by n plus 1, which is equals to what? X power minus 2 plus 1 divided by minus 2 plus 1, which is equals to what is the answer, Ra? Minus, yesterday also we studied, minus 1 by x. Understand, Princey, Mane and Samya? So that's all. So integration of minus 1 by x and limits is what? From infinity to R. Anybody having any doubt, you can ask me. So this one, minus G M1 M2, and I will substitute the limits, which will turn up into minus 1 by R and minus of minus 1 by infinity. So minus 1 by infinity is 0, which is equals to minus into minus plus. So I'll get G into M1 into M2 divided by R. So it is a positive or negative R? Tell me, everybody. Work done by the gravitational force by second body. It is positive or negative R? Everybody. Yes, please. Got it? Positive. But we need to get it what? Actually, it has to come what? Negative. Am I right or wrong, guys? So let us verify it now. Sir, why, sir, it is positive? Means it's very simple. The force is also acting because we are moving the body mass M2 in this direction and the displacement also in the same direction. So both are same direction means positive or negative or 9th class. Both are same direction. Force applied is also same direction and displacement also same direction, M2. Is it, tell me, everybody, positive or negative? Yes, please.
Positive.
Positive. So now let me take now body is M1 and M2 is came into a particular distance, which is what is R. Then U configuration. So what is the U configuration actually? U configuration means final, that is what? Final minus initial, which is equals to minus of work done by the gravitational force. Any problem for anybody in the formula? Please respond. Everybody? Clear? So what is the potential energy at the infinity, which is equals to 0? So U configuration, potential energy of a configuration is equals to minus of, what is the work done by M1? Work done by the M1, which is equals to what, guys? 0. Clear? Please respond. Plus
Sir.
work done by the gravitational force on 2, M1 not 2. This is 1 and this is 2. Sorry. This is 1 and this is 2. What is the 2? G into M1 into M2 divided by R. So now 0 plus anything, same thing, minus into plus minus. So minus G into M1 into M2 divided by R. So this is the potential energy of a given configuration. So anybody having formula, anybody having any doubt, you can ask me. This is for any bodies, 2 bodies, 3 bodies, 4 bodies, 5 bodies, 10 bodies, let them. So always this is the formula for calculating potential energy of a given system of configuration. Any n number of bodies, doesn't matter. This is the formula which you have to remember. I hope you all understand how to make it. Anybody having any doubt, let me know, or else we'll proceed. So please solve it, everybody. Are you clear, everyone? Please respond, guys. So what is the potential energy of a configuration? Formula minus G M1 M2 divided by R. Once again, I'm saying 2 points. One is, it is not possible to define the potential energy of any one single body. Always we can define, according to physics, always we can define how many? The change in potential energy of a 2 bodies. And the second point, whatever the body is at infinity, then the potential energy of the system is what? Infinity distance means potential energy is equals to what? Everybody, please respond. 0. And if we have to bring that mass to particular configuration, so that particular configuration U is equals to minus of work done by the gravitational force, which is actually bringing the mass from infinity to that particular place. So that formula is minus G into M1 into M2 divided by R. And this is the derivation for the gravitational potential energy, which is the formula is minus G into M1 into M2 divided by R. So till here, anybody having any doubt, you can ask me, or else we'll proceed further. Rudreswar, are you clear? Mr. Pradeep, Pradosh, everybody? Any doubt, you can ask me. Are you clear, everyone? So, but this what this is work done by what? Internal or external? That is what is my question. It is work done by what, everybody? It is work done by gravitational internal forces. So that is what it is always remember. So a potential difference of any kind of system, that is what configuration, that is what we can say. Change in potential energy is equals to minus of work done by the gravitational force in bringing the mass from infinity to that particular configuration, which is also equals to work done by the external forces. That is the major important thing which you need to remember. We are going to study this only. So change in potential energy of a system is equals to either work done by minus of work done by gravitational force, bringing the mass from, understanding, bringing the mass M from infinity to particular configuration, or which is also equals to plus work done by what forces? Internal or external? This is by what forces, everybody? Internal forces. Now this is what? Positive work done by the external forces, which is also equals to change in potential energy of a system. So that is what you have to remember. But always keep it in mind, GPE, gravitational potential energy, is always what? Negative or positive? Everybody. Always it is what, everybody? Gravitational potential energy, which is always negative by the internal forces. But it is same work done is positive when it is work done by the external forces. That is what you have to remember. Understand, everybody? Clear? Please respond, everyone.
Yes, sir.
Yes. So now, sir, let me see either it is positive or negative, so we can make it that also. So all of you remember, all of you. So always potential at infinity is 0, field at infinity is 0, and potential difference also at infinity is what, everybody? Please respond, 0. Clear, everyone? Please respond, everybody. So always keep in mind, you can take the potential configuration, potential energy of a configuration. You remember well, all of you, we can say change in potential energy. Always you can take two definitions. One is either minus of work done by the what forces? Anybody? Minus of work done by the what forces? Gravitational. Respond, everyone. Gravitational internal forces, or which is equals to, because if the internal forces, work done by the internal forces is minus, opposite means, then work done by the external forces is what, everybody? Work done by the external forces is positive. So gravitational potential energy, two definitions, either minus of work done by the gravitational force, that is what, internal, from bringing the mass M from infinity to the configuration, or work done, positive work done by the external forces. That is what is the definition. Anybody having any doubt, you can ask me. Are you clear, everybody? Please respond, guys. All of you?
Yes, sir.
Yes. Now, so let us prove the second derivation, second formula, and we'll derive the configuration of a system. So now if I take, let me take change in potential energy is equals to positive work done, external force, positive work done. So now let me consider two masses m1 and m2 is present at what distance? Infinity distance. Now I have bought m1 mass. I have bought m1 mass. Okay. Now I want to see which is at to a point P, which is what r away from the m1. So now you can notice it. Can you tell me what is the work done by the external force on one body? Bringing one body is always what? If you bring external force or internal force, does not matter. So always m1 is equals to what? Work done by the m1 always is what? Single force means, single body means always work done by the single, work done by the external force, which is always equals to what, everybody?
0.
0. So now I bought the second mass to a certain distance. Certain distance, that is what? Now this distance is not remains constant. So can you tell me what is the formula, Rudreswar? Work done by the external force on second body is equals to integration of, what will happen, guys? F dx. That is what? Force exerted by the external force into dx. That is what you have to remember. Are you clear, everybody? Yes?
Yes, sir.
But you should not supposed to use this one. It is not required. Not use for external force. Don't, not required or necessary to use this one. If you use this one also, you will get the work done by the external force is the same answer. So let us verify. If you want, you can solve like this also, but it is not required to do it for the external forces. So always keep in mind, work done by the external forces, okay, by the second body is equals to mass of the body into change in potential. This is the formula which you people need to use for external forces. So please remember, all of you. So what is the formula for external forces, everybody? Mass into change in delta V. That is what? Change in potential. So that is the work done. That is the work done by the second body. So now work done by the second body is equals to m into delta V. And we all knows that m is equals to what? Second body or first body? That m is equals to what? First body or second body, everybody? Second body. That is what? M2. M2. And can you tell me what is the change in potential? Change in potential formula for those? Final minus initial. That is what? V final minus V initial. So V initial always will take it as a infinity. So V final is equals to a particular distance R. So that is what? VR. So VR minus V infinity. So what is delta V, everybody? Delta V is equals to what, everybody? Please respond. V final minus V initial. V initial. So V final is VR, V initial is V infinity. So I will modify the formula delta V into, okay, delta V into VR minus V infinity. So this is what you have to remember. So now we all knows that work done by the external force, work done by the external force, at infinity. So what is that? V infinity is equals to how much, everybody? All of you please respond. V infinity is equals to what? Everything. At infinity distance, everything will become what, guys?
0.
0. Clear? So now, you remember, if I take that one, so work done by the external force is equals to m into delta V. Now you can see the same, if you notice it here, so I will take it for m1 mass. So which is, let's imagine, m1 mass, what is the gravitational field from the point R? Sorry, potential from the point R. Can you tell me? Let me imagine at the point R, this is the point. I want to know the V at this point. What is the formula? V for this point P. We already have done. Anybody? V for this point, which is equals to what? Everybody? Minus G into M1 divided by R. Am I right, guys? Please verify, guys. Everyone? You have done or not, Pradosh? Yes, please. All of you. Respond, Ra.
Yes, sir.
Yes. So which is equals, I'll replace it now. So what is the formula? Here delta V means VR. Okay, VR minus V infinity. So now you can see M2 into, I will change it into, so what is that, everybody? VR minus V infinity. So we all knows that V infinity will become what, everybody? V infinity will become what? 0. Now VR, what is the VR at the particular point? What is the V, guys, at a particular point? Speak, guys.
minus GM.
Minus, that is what work done by the external is equals to M2 into minus G into M1 divided by R and minus 0. So which is equals to, you can notice it, this minus into plus, it is minus, and G into M1 into M2 divided by R. So this is only actually which is equals to work done by the external force. That work done by the external force is equals to only, we can say, change in potential energy. That change in potential energy means what? Final potential energy minus initial potential energy, which is equals to minus G into M1 into M2 divided by R. So we all knows that V is equals to infinity. Then U infinity equals to what, everybody? Yes, please. U infinity is equals to what? 0. So potential energy of the configuration is equals to minus minus G into M1 into M2 divided by R. So this is the formula. Again, if you take even work done by the external force, if you take it also, again we got what is the configuration, everybody? We got the same answer. Am I right or wrong? Verify it, everybody. Please respond, guys.
Yeah.
Yes. So work done by the external force is same. Clear, everybody? Work done by. So that is why we can say from this, what we can say, guys? So potential energy, the configuration, potential energy of a configuration is equals to, what is that, everybody? Minus of G into M1 into M2 divided by R. So this is the formula which you need to remember. Anybody having any doubt, you can ask me. So two formulas for change in potential energy. Can you tell me what is that? Two formulas for change in potential energy. One is what? Minus of work done by the gravitational force. Gravitational force for bringing the mass from infinity to the configuration, or which is equals to work done by the what forces, everybody? Work done by the external forces. Minus of work done by the internal forces are equals to plus work done by the external forces. Any doubt? Anybody can ask me. Anybody? Are you clear? Pradosh, Rudreswa, Sai Karthik, understand, Tambi? Princy?
Yes, sir.
So this is the formula. At least formula you try to remember. So what is the gravitational potential energy formula, everybody? Gravitational potential energy of a configuration is equals to, what is the formula, everyone? Minus G into M1 into M2 divided by R. So this is the formula. So anybody having any doubt, you can ask me. Now, for example, sir, two bodies is given. This is what is the formula. For example, three bodies is given. All of you observe. This is M1 mass, which is present at R12. That is what? R distance. And this is the M3 mass, which is present from R13. And this is R23. So this is what it is. Now, sir, what is the potential energy of this configuration? So how many body configuration here? Two body or three body? Everybody? How many?
Three body.
Yes. So now if you observe very carefully, three body configuration, sir, how to find it means, so potential energy of a configuration is equals to potential energy of 1, 2 plus potential energy of 2, 2, 3 plus potential energy of 1, 3. Because minimum how many bodies we have to take it always? Two bodies are in contact. Clear, everybody? So 1 and 2 contact, or 1 and 3 contact, or 2 and 3 contact. So totally how many, everybody? 3. Understanding? Please respond, everyone. Clear? Yes?
Yes, sir.
Yes. So what is the configuration? What is the potential energy of M1 and M2? Can you tell me? Formula. Potential energy of M1 and M2. Minus G into M1, M2 divided by distance is R12. Am I right, guys? Speak, guys. This is what?
Yes,
M1 and M3. What is the formula? Minus G into M1 into M3 divided by R13. What is the configuration of M1, M3, M2 and M3? Anybody? Minus G M2 into M3 divided by R13. That is only the thing. So everything plus into minus, it will become minus only. So I'm directly writing minus G into M1, M2 divided by R12 plus of minus G into M1, M2, M1, M3 divided by R13 plus of minus of G into M2, M3 divided by R23. Are you clear, everybody? Please respond, guys. Then plus
Sir.
into minus, if you remove it, yes, brothers, tell me. Are you clear?
Yes, sir.
Plus and brothers. So minus G is common. If I take minus G is common, then remaining what is there? Can you tell me? M1, M2 divided by R12. Understand?